So that was one problem with DES. But another problem was that by the 1990s, a 56-bit key was already too small. Computers at the time were starting to be able to perform the brute force attack of just trying all possible keys to decrypt a message. 3DES solves this problem by making the key 3 times as long and using DES 3 times with those 3 different keys. It's not quite the same as encoding with the first key and the second part of the key and the third part of the key. Instead, you take this low part of the key, do the encoding as you would expect, but then do a reverse encoding or the decoding step with the second part of the key, and then go back and do an encoding step of the first part of the key. So this is like running the encoder 3 times with 3 different keys, but just for some variety, running it in reverse in the middle step. So that is overall how you take this larger key, 3 times 56 or 168 bits, to get much better encryption with DES. It can still use all the same implementations and hardware implementations because it's using the algorithm 3 times. And there was DES hardware. In fact, the design took into account that custom hardware was going to be made for it, and these bit permutations that are represented by these P boxes, they can be implemented with shifts and ORs in a generic CPU, but they're a pain to implement that way, and they're somewhat slow. So this motivated looking for a new algorithm that was a little bit better fit to CPUs of the time, that combined with the distrust of the process that it produced DES, especially those substitution boxes.